Hi, my name is Scott. I'm from the Economics Tutoring Center, and today we're going to be conducting an AnovaTest for the equality of 3 population means. Please make sure to check my notation and language use with your professor because it may vary. Okay, so we have a problem here where testing the null hypothesis that 3 different population means are equal. So, we don't necessarily know what these populations are or what the means are, but we can use the ANOVA procedure to test whether they're equal. So there's some information already given to us. We know that the overall sample size is 12, meaning there are 12 total observations. And then when we do the critical value and actually make a conclusion from the test, we're going to use a significance level of 0.05. And then we are also given that the sum of squares due to treatment is 614. And the total sum of squares is 1,212. And then basically given this information, we need to fill in the rest of this table, find the F statistic and the F critical value, and then make a decision about our test. So with this information, I think the first box we can fill in is this one, the sum of squares due to error. So there's an important equation that we can use to find this one. So that is that the sum of squares due to treatment plus the sum of squares error is equal to the total sum of squares. And we can rewrite this by subtracting sum of squares treatment over to the other side. We get that the sum of squares due to error is the sum of squares total minus the sum of squares due to treatment. Now if we plug in the numbers we already have for those, we get 1,212 minus 614, and that will give us, if you do that in your calculator, that will give us 598 for our sum of squares due to error. The next column, we probably want to fill in the degrees of freedom column next. So there are different values for degrees of freedom for the treatment, the error, and the total. So something important to know is that the degrees of freedom for treatment is k minus 1. And what k is it's the number of groups that you're testing for equality. Meaning, if you look at this null hypothesis, we're testing that 3 different population means are equal. So k equals 3 in this case. So if the degrees of freedom due to treatment is k minus 1, then in this example it's 2. The degrees of freedom due to error is n minus k, and by n I mean the total number of observations, not just the number of observations within a specific group. So we have our n is 12, k is 3, so our degrees of freedom error is 9. And then our total degrees of freedom, which may look the most familiar, is equal to n minus 1. And n is 12, so in this example we have 11 degrees of freedom total. And if you'll notice, if we add the degrees of freedom for treatment and error, we get the total degrees of freedom. That's because k minus 1 plus n minus k gives n minus 1, because these k's cancel out. So then, alright, we have those 2 columns. The next one is our mean squares. That's what MS stands for. And the equation for this, and this is true for all of these numbers in this column, you take the sum of squares divided by the degrees of freedom for the appropriate row. So for example, the mean squares due to treatment is the sum of squares due to treatment divided by degrees of freedom treatment. So that would give us 614 divided by 2. If you put that in your calculator, that will be 307. Now, similarly for error, we take the sum of squares divided by degrees of freedom. So 598 divided by 9. If you do that one in your calculator, you should get 66.444 approximately. And finally, for the total degrees of freedom, we don't actually typically calculate the mean squares total because it's not meaningful in the ANOVA procedure. We only need mean square error and mean square treatment. So the F statistic is the final thing we need to fill in this table, and that is equal to mean squares due to treatment divided by mean squares error. So in this case we have 307 divided by 66.444. So we can equals 307. And if you put that into your calculator, you'll get an F statistic of approximately 4.62. So now we have the whole table filled in, the ANOVA table. We need to decide whether we reject or fail to reject the null hypothesis. So the rule for that is F value is greater than or equal to the critical value, which I'll denote by this subscript 0.95. Then you reject. And then the opposite case is if your test statistic is less than the critical value, then you fail to reject. And the reason I put 0.95 next to this F value is because we're using the alpha equals 0.05 level of significance. So sometimes you'll see this with just the 0.05 subscript. Other times you do 1 minus alpha as the subscript. But either way, it denotes the critical F value at the 5% level of significance. And you find this from the F table. And if you recall from the F table, you need 3 things. You need alpha equals 0.05. You need numerator degrees of freedom, which is this degrees of freedom due to treatment, basically. And then your error degrees of freedom, or denominator degrees of freedom. If you use all those things on the 5% F table, then you'll get that your critical value is 4.26. So then we can finally make a decision about this test. We found that our F star, or our test statistic, is 4.62, and that is greater than 4.26, our critical value. So based on this rule, we would reject the null hypothesis. So if you recall, this was the null hypothesis. The fact that we're rejecting it means that not all 3 of these means are equal. So it could be the case that maybe mu2 and mu3 are equal, but mu1 is not. Or, it can be any combination. Maybe none of them are equal to each other. All we know is that it's not the case that all 3 are equal. If you want to test which ones are equal and which ones aren't, you can use separate t-tests for that. But that's how you test this sort of null hypothesis. That's all we have today about ANOVA, testing the population means for more than 2 populations. I hope it helped, and if you have any further questions, come into the tutoring center or ask your professor for help.